Welcome to the DIY Honda Garage channel. DTC P0452 indicates an issue in the FTP, fuel tank pressure sensor circuit, with low voltage readings. This code suggests that the voltage signal from the FTP sensor is below the expected threshold, typically around 0.3 volts or less. The FTP sensor is a critical component of the onboard evaporative emission control system. It monitors the fuel tank vapor pressure to prevent fuel vapors from escaping into the atmosphere. In Honda Civics from 2011 to 2015, this sensor is typically located on or near the fuel tank and is connected by wiring to the engine control module, ECM. When this error occurs, it can affect the vehicle's performance and emissions control system, potentially leading to increased emissions and decreased fuel efficiency. The FTP sensor plays a pivotal role in the fuel evaporation monitoring system. Its primary function is to measure the vapor pressure within the fuel tank, which helps ensure that the emission control system works efficiently. Typically installed near the fuel tank, the FTP sensor connects to the engine control module, ECM, through a wiring harness. This connection allows the ECM to interpret the sensor's readings and adjust fuel delivery as necessary to minimize emissions. When the FTP sensor reports low voltage, it may indicate a fault in the sensor itself or in the related circuitry. Addressing this issue is crucial to maintaining optimal vehicle performance and environmental compliance. Several potential causes can lead to the P0452 error code. Firstly, a defective FTP sensor can produce incorrect signals to the ECM, causing low voltage readings. Additionally, wiring issues such as short circuits or open circuits can interrupt the signal flow between the FTP sensor and the ECM. Malfunctions within the ECM itself can also manifest as erroneous readings from the sensor, although this is less common. Lastly, poor connections due to corrosion, wear, or loose terminals can hinder the electrical flow, resulting in inaccurate voltage levels. Diagnosing the exact cause requires careful examination of each component and its connections. Following the outlined troubleshooting steps, the P0452 code can manifest through several symptoms. The most common indication is the illumination of the check engine light on the dashboard, alerting the driver to a fault. Additionally, the vehicle may fail an emissions test due to improper vapor regulation from the fuel tank. Drivers may also notice a gasoline smell around the vehicle, suggesting vapor leaks that are not being properly managed. Lastly, there might be symptoms relating to engine performance, including rough idling or stalling, caused by the ECM compensating for what it perceives as an issue with the combustion process. Recognizing these symptoms early can lead to a more efficient resolution before worsening occurs. To begin troubleshooting DTC P0452, start by turning the ignition switch to the on/to position, allowing the onboard diagnostic system to initiate. Use the HDS, Honda Diagnostic System, to clear the DTC, ensuring that any previous fault codes are removed from the system's memory. Next, safely remove the fuel fill cap, as this will allow the system to register any changes in pressure when the engine is running. After this, turn the ignition switch back to on/to access live data. Monitor the FTP sensor reading in the data list with the HDS. It should show approximately -7.3 kilopascal, -2.16 inches, or -55 millimeters Hg, or 0.3 volts or less. If the reading matches these values, proceed to step 3. Otherwise, go to step 2. In this step, after recording the initial readings, reinstall the fuel fill cap securely. Start the engine and allow it to idle so the vehicle can reach its normal operational state. While the engine idles, Utilize the HDS to monitor the OBD, onboard diagnostic status, for any indication related to DTC P0452. If the HDS shows failed, this confirms that the issue is reproducible, allowing you to move forward to step 3. However, if the system indicates past or intermittent failure, it signifies the system is functioning correctly at that moment. Return to inspecting the connections at the FTP sensor and the ECM to rule out any loose connections or faulty wiring. If the HDS indicates not completed, continue idling until sufficient data is retrieved. For the next step in troubleshooting, turn the ignition switch to the lock 0 position to ensure all systems are powered down before making any adjustments. Once the vehicle is fully off, disconnect the FTP sensor by removing its 3P connector. This action isolates the sensor from the rest of the electrical systems. With the connector detached, turn the ignition switch back to on. Second, and use the HDS to check the FTP sensor data again. Confirm if the reading reflects approximately -7.3 kilopascals, -2.16 inches of air, or -55 millimeters of air, or 0.3 volts or less. If it does, proceed to step 4. If not, move on to step 5 for further investigation. In step 4, again, turn the ignition switch to the lock 0 position to ensure safety during testing. Use the HDS to jump the SCS, service check socket line, enabling the diagnostic system to enter test mode. Next, disconnect the ECM's A connector, 49P, to isolate it from the circuit. After this, you'll need to check for continuity between the test points between the FTP sensor 3P connector and body ground. The testing conditions specify using the FTP sensor 3P connector in the disconnected state and the ECM connector likewise disconnected. If continuity is present between these test points, there may be a short in the P-tank wire and repairs will be needed. If there is no continuity, the P-tank wire is intact, leading to potential ECM issues. In this troubleshooting step, the ignition switch must be turned to the on second position while keeping the FTP sensor 3P connector disconnected. Use a multimeter to measure the voltage at the test points, specifically between the FTP sensor connector number 3, red, and body ground. It is crucial that the reading shows about 5.0 volts for proper operation. If you verify this voltage, it indicates the wiring is intact and the issue lies with the FTP sensor itself. A replacement will be necessary. Conversely, if the voltage reading is not at the expected level, this suggests a problem within the VCC6 line, indicating further investigation is warranted in this circuit. For step 6, the ignition switch should again be brought to the lock 0 position for safety. Utilize the HDS tool to jump the SCS line, entering the diagnostic testing mode. With the HDS engaged, disconnect the ECM connector A, 49P, to enable focus testing of the VCC6 circuit. Connect terminals A and B using a jumper wire for testing purposes. Terminal A refers to the FTP sensor 3P connector number 3, red, while terminal B is connected to body ground. This step checks for continuity in the VCC6 wire, which is vital for the FTP sensor's operation. If continuity is restored, the VCC6 wiring is likely functional. In this case, it's recommended to either update the ECM software or replace the ECM with a known good unit. If the continuity test fails, this indicates a break in the VCC6 line, which requires repair. After completing all necessary repairs, verification steps are essential to ensure the issue has been resolved. Begin by turning the ignition switch to the lock 0 position and carefully reconnect all previously disconnected connectors to their respective positions. Then, turn the ignition to the on IT position to apply power to the system and prepare for diagnostic tests. Use the HDS to reset the ECM, which allows it to re-establish communication with all connected sensors and systems. It's also crucial to perform the ECM idle learn procedure, ensuring that the engine management system adapts to any changes made during repairs. Finally, monitor the OBD status for DTC P0452 using the HDS to determine if the status reflects passed, indicating successful resolution, or any other status which would prompt further investigation. Preventive maintenance plays a critical role in avoiding future issues related to DTC P0452. Regular inspections of all connectors, particularly near the fuel tank and ECM, can identify signs of wear and corrosion before they lead to faults. Corrosion can impact the connectivity and reliability of electrical signals, potentially triggering diagnostic trouble codes. Keeping the ECM software updated ensures that the vehicle benefits from improvements and bug fixes provided by the manufacturer, which can optimize sensor performance. Lastly, routinely checking the integrity of the wiring harnesses can prevent shorts and opens caused by physical damage over time. Employing these preventive measures can enhance vehicle performance and prolong the lifespan of critical components. In conclusion, DTC P0452 signifies a low-voltage condition in the FTP sensor circuit, directly affecting the vehicle's emission control system. The FTP sensor is vital for accurately monitoring fuel vapor pressure and ensuring compliance with environmental regulations. Following the discrete troubleshooting steps is essential to pinpoint the exact cause of the issue, whether it be related to the sensor, wiring, or ECM. A systematic approach not only facilitates effective repairs, but enhances diagnostic confidence. Furthermore, incorporating routine preventive maintenance is crucial in mitigating risks associated with electrical faults and keeping the vehicle operating within optimal performance parameters. Understanding these practices can lead to a more reliable and efficient driving experience. Please like and subscribe to the channel. See you next time.